Hi, everyone. Oh my God, it's a lazy afternoon after lunch. Okay. My name is Vandana, and I'm honored to serve as a review board member and here introducing our speakers. So thank you for joining us at AI-powered image-based command and control framework. So they'll be utilizing AI models to conceal and extract commands in C2 images. So we have wonderful speakers, Chen Fang, security researcher, Palo Alto Networks, and Chris Navarte, principal security researcher, Palo Alto Networks. Please join me in welcoming Chen and Chris on the stage. The stage is all yours.
Thanks for this introduction. In this talk, all the opinions are our own. It does not represent our employer. Before we delve into the technical details, I would like to give the first introduction about image steganography. It's not new to security. Basically, attacker can hide their payloads into the image using an encoder and decode from it. Usually, attacker need to have the knowledge about the image itself to design their own encoder and decoder algorithms. For the deep image steganography, in this case, it utilizes the neural networks to automatically learn how to encoding and decoding the data. In this case, we don't necessarily need the knowledge about the image itself. We can directly use the neural network to train the model for encoding and decoding for us. In this case, the encoder and the decoder are actually AI models. So this could be bypass the existing detection service, which utilizing the binary analysis or some code analysis. In this talk, we would like to explore how practically we can design the neural networks for encoding and decoding malicious payload, and how practical we can train the model for attacks, how practical we can enhance the C2 frameworks with the AI model. So the better we can know how attacker utilize the AI model for the attack, the better we can provide the defense against them. So here is the architecture about our AI stagger model. We have the secret to tensor and image to tensor to convert the secret or payload to tensor and convert the image to tensor for encoding and decoding purpose. And we also utilize the secret reconstruction loss and the image reconstruction loss to guide our training quality. Let's talk about the details. First, we need to convert the image to tensor. It utilizes two steps. First, we need to load the image into the tensor format using the standard PyTorch library. And then we need to do the normalization on those tensor. Those are standard steps for the image processing. Here's some example we can see. And now we have to convert the malicious payload into the tensor. In this case, we need to first convert the malicious payload into the bit array, and then we use the standard PyTorch library to load those array into the tensor format. Here is some example. We also visualize those malicious tensor into image format. Now we need encoding for them. We have the image tensor, we have secret tensor. Now we need to do several steps for encoding purpose. First, we need to convert the secret, reshape the secret, and repeat the secret into some tensor with the same dimension with the original secret, with the image tensor. Now we need to do some feature learning on the image itself to learn the higher feature vector. And after that, we have to concatenate the secret tensor and the higher level feature vector of the image and image itself into the tensor for encoding purpose. In this case, the encoding and the feature learning part are actually a set of container. Each of container consists of multiple layers. They have the convolution layer and the batch norm layer and utilize ReLU active function for that purpose. Now we get the stagger image through the encoding. The decoder part actually gets the stagger image from encoder and utilize a set of container to learn the representation for the decoded message. And we also need to conduct several average pooling and linear conversion to convert those tensor into the decoded secret tensor. This secret tensor should share the same shape with original secret tensor. But we also need to do additional step for that, the round operation. Why? Because the output for the decoded secret actually are floating point. So we need to convert each entry in those tensor into 0 and 1. And after that, we consider the decoded rounded tensor 0, 1 as a beta array. And then we can extract the command for that. Here is some example. We have the encoder and decoder. We have to utilize the loss function to get our training quality. We utilize the mean square error to reconstruct the image, quantify the image reconstruction loss, and we use L1 loss to quantify the secret reconstruction loss. Now we need to train the model. We have two training tasks. Firstly, we want to train a generic model. Means that we can hide the arbitrary data into the encoder and decode for it. And the second task, we want to train the specific data hiding. So in this case, we only train the model on small set of data with small set of payload. And then we overfit the model to try to get the higher accuracy. Here is our evaluation results. We can see for the generic data hiding part, even we train it for 40 hours, we can still not get, we can get 0 reconstruction success ratio. That means that we cannot get any decoded secret successfully. So but on the other side, for the specific data hiding, we can finish within few seconds and get 100% reconstruction success ratio. This means that the specific data hiding could be more practical and to be used for attacks. Now we also evaluate the performance for the specific data hiding. We show the correlation between the payload and the training time on the left and the model size on the right. We can see as our payload size increase, the training time also increase, and the model size also increase. It's obvious. But when we look at, if we want to encode 100 bit malicious payload into the image, we can finish within less than 1 minute. And the model size is smaller than 6 megabytes. So this means it's practical, still practical for our attacks. Now we also want to discuss how the encoding and the decoding logic for the neural networks. So we train the model twice. With the same setting, same payload or different payload. And we visualize the diff image between the staggered image and original image. We show each of the different image in each row. The round 1 means the training once, and round 2 means that we second training. We can see even within the same training setting with the same payload, the diff image looks slightly different. Even the staggered image looks the same. This means that we train the model twice with the same setting, the C2 image looks different. It's good for attacker because it can easily bypass the signature-based C2 attacks, C2 image detection. And we also see that the decoder actually are a set of convolution layer operation. They have some kind of convolution operation. This is a nonlinear operation. That means that even we have the cover image, we also have the staggered image. It's hard for us to reconstruct those malicious payload without a decoder. So why we utilize the specific data hiding for C2 attacks? First thing, the attack needs 100% reconstruction ratio. And our specific data hiding can achieve this goal. Secondly, with the training required for specific data hiding can be conducted at the C2 server side is more reasonable. And those two things make our specific data hiding perfect fit into the C2 attack scenario. Now let's hand over to Chris for our to showcase our C2 framework. Thank you.
All right, perfect. Thank you, Shan. All right, so let's discuss about the prototype design and implementation of our C2 framework. First of all, let's understand the C2 attack flow. So we have a C2 client, and also we have a C2 server. So the very first step is training the model. So the second step is going to be the hosting of the model and the image artifacts that are being generated as well. On the C2 client side, we are retrieving the ML model that we just created. Step number 4 is the retrieval of the requirements TXT file. So this file is basically the libraries that are going to be used by the C2 client in order to process the machine learning model. The step number 5 is the retrieval of the staging key. So in this case, the C2 client is retrieving the image file. So the image file, it will be passed to the machine learning model to extract the information which is inside of it, and then it is going to be used for encryption purposes. The next step is a C2 check-in. So at this point in time, the C2 client and the C2 server are fully completed this C2 communication. Step number 9 is the search for this new task. So in this case, the C2 server is just commanding the C2 client to consume the tasks that are going to be pending. And then after that, the C2 client will be retrieving new images, and then it is pretty much the same process. It's going to be passing through the machine learning model, extracting with the Conceal content, which is a operating system command, running it, and then after that, all the collected information will be returned to the C2 server in an encrypted manner. So now we have the C2 client server component. So we have the C2 manager, which is an API endpoint. So the purpose of this is just handling the checking and also the beaconing that is being produced. On the right side, we have the C2 web controller, which is a PHP page in where it is pretty much controlling the information which is being exfiltrated by the C2 client. Also, the C2 web controller is just in charge of the hosting of the different scripts, in this case, supporting scripts like for decryption purposes. We have also the model hosting, we have the images as well, and also the requirements TXT file. Finally, we have the machine learning model, which is the trainer part. In this case, this trainer is in charge of crafting new images. And then also we have a C2 client, which is a Python-based implant. So now we have a fully working prototype, which is called image C2. We have 5 operational commands that are who am I, system info, task list, ipconfig. Also, we have a payload execution command. So in this case, we have a PowerShell, reverse shell, which as the name says, so we are expecting to have reverse shell after the execution of this. So there should be a way for the image C2 controller and then to be some kind of mapping against the client. So in this case, we have different response IDs, in this case from 1 to 5, and those are pointing to the specific file name that we will be using. So in this case, we have different images for different commands. And also, for example, in the last one, we have a PowerShell, which is a one-liner. So this is the way that the Python C2 client is processing the image and then extracting the information. So we are calling 3 different functions. The very first function is the read command. So we're just passing the absolute path of the image file. And then eventually we will be calling the load image and get CMD. So all of this information is passing through, pointing to the actual model and the image tensor. After that, the machine learning model, it will be handling this input, and the output will be pretty much the one-liner that we have that we have as a PowerShell payload. So for that, now that we know that the C2 client is performing these actions, so we just need to perform some encryption and encoding. So in this case, we have a specific class in where we are using the staging key in order to encrypt this information. So we will be using the HTTP protocol to do that, and then we have a dictionary in where we are pretty much encrypting and using base64 encoding for later exfiltration. So we use different Python libraries. In this case, the Cryptodome, Hashlib. We have also AES-P56 in GCM mode and script PDF in order to use a password and to encrypt this information. So this is how the request looks like. So as you can see, we have different HTTP body, we have the parameters, we have the key names. But the objective of this is just to pretty much sending this ciphertext, the salt nonce and tag to the C2 server for further decryption. And then the data extraction and exfiltration is just a kind of a way that you can illustrate the traffic which is going on. So the very first request in blue is just the request of the image file. So as you can expect, so this is just a flat image, there's nothing else. So the C2 client will retrieve this image. It will be hiding the secret, executing the command. As you can see, this is a result of the who am I result. And then after that, encrypting the data, and we'll be proceed with the exfiltration of it to the C2 server eventually. So now that we just discussed about everything, let's see how it looks like under the Wireshark. So we will discuss about the C2 staging and post-exploitation. So the very first stage is stage 0. So in this case, we are downloading the model. Stage 1 is the downloading of the requirements.txt file, with containing all the libraries that are required for the C2 client to process the model. Stage number 2 is the staging key retrieval. So staging key, as I mentioned earlier, so it's going to be used for encryption purposes. And then we have the stage number 3, which is the C2 checking. Then we have the C2 beaconing. As you can see, we have different HTTP requests trying to look for any activity from the C2 server. When there's a new task which is being found, it's going to be retrieving an additional image. So in this case, we have an image.jpg, which is eventually calling to the who am I command. And then finally, we proceed with the data exfiltration. But let's take a better look about like how everything looks together with that demonstration. So what we have here is the on the left side we have the C2 client. On the right side we have the attacker machine. So we initialize the image C2 tool. So it is up and running, looking for any connections. So next step is just running the C2 client. So as we can see here, we're just downloading the machine learning model. This next step is the download of requirements.txt file, retrieving the staging key, and proceeding with the model execution. So as you can see, we are passing the image path in a temporal location, calling to the model. And eventually, the staging key or the encryption key is being retrieved. We do the checking. On the server side, you will see that there's a connection also happening. We see the beaconing happening on the C2 client part. Then after that, we are going to introduce a new command. Well, it's who am I? So the image retrieval is happening. So obviously, since before we just downloaded the artifacts, so there's no need to do anything. We are just pretty much focusing on the extraction, the retrieval of the images and processing after that. So we wait. We see some activity happening here, which is basically the command extraction and execution. Then after that, we collect the information, we encrypt the information, and we proceed with the exfiltration. So as you can see, we see the dictionary, which is containing all the different information, which we pass it to the C2 server. After that, 10 seconds check. And we got the result. So at this point in time, the C2 server just got the information, proceed with the decryption, and obviously presenting it in the console. It is looking for additional tasks. We are providing another command, system info, going through the same procedure, different image, exfiltrating data. We see the result. And then we are going to see more commands, pretty much the same concept. We know what's going on here. Obviously, as expected. And then we will have an additional command. So in this case, let's do a little more like fancy. Let's do the PowerShell reverse shell. So as you can see here, we are initializing a listener in port 8071. We will see the activities happening on the client side. So at this point in time, you see the PowerShell gets executed. You see that the bytes are being written. And also, we are about to see the reverse shell happening here on the right side. So we got the access to the remote machine. We are going to interact a little bit more with it. And then we got the response. And yeah, so that we pretty much exit the session, the reverse shell session. All right, perfect. So Conclusion. So today we showcased the AI Stega model and the AI enhanced C2 framework. Also, we showcased that we can use images to conceal commands, right? We also use a malicious model as well, and also we crafted C2 communication. So altogether, pretty much like creating a really interesting case that for detection and defense mechanisms, you want to say. The further development is we want to provide a better or advanced model for the AI enhanced C2 framework. And also, we want to extend the supported C2 payload execution and operational commands. So we are also adding some reference here. So we use them during our research. Well, and I think with that, we conclude with our presentation and we're open for any questions you may have.